Hi, I'm Mr. V, and this is lesson 24. It's not from illustrative mathematics, but it goes along in hand with illustrative mathematics, chapter 21. Lesson 21 was on the triangle angle sum theorem. And this is some of the more mathy problems, triangle problems set that I have put together to help you with your understanding of triangles. If we go to the objective, today's lesson, you will be able to say, I can use what I know about triangles to solve problems. And the first thing we're going to do is do a card sort. In this card sort, we'll first sort things by their sides. And card sorting by classifying triangles is not I'm going to close this down a bit. It's not a 10th grade or 9th grade Common Core standard. It's from an earlier grade, but the questions that I've asked today are for the 10th grade and 9th grade. They make it a little bit more challenging, and you'll see that as we go along. First of all, equilateral, I'm going to put the equilateral, equiangular together. Both of these are also isosceles. Isosceles means that at least two sides are the same, but I give this its own category because I want to point out that it's a special case of the isosceles. So all equilateral triangles are also isosceles, but we put them in a separate category here because this makes them special. To be isosceles, two sides will be the same, so I'll put these over here. Let's see, if all sides are different, as marked here, that's scalene. That's what it means to be scalene. When your answers match, this will be a yes. Here we have two angles are the same, which means that the two sides would also be the same. All three angles are different. This would be scalene. And we have these three are all different, so this would be scalene. All three are different. And this last one, I don't know the third angle, but I know that the three angles sum to 180. So if I were to take this, I'll copy it over to my whiteboard and show you what I would do. I'm going to sum the two angles, and I will subtract them from 180. So the equation is the angles of a triangle sum to 180. If we called this x, we would have x plus 64 plus 58. And when we subtract this from both sides of the equation, we get x is equal to 58. Oh, two of the angles are the same, this one and this one. That makes this isosceles. So we can put this card back where it belongs, into the isosceles bin. And when we do that, our changes to yes. On this next page, you get a scale that shows you how much of how many of the 13 cards you got correct. And it asks you, how did you know, without guessing, which category to put card 10 in? Card 10 was this one. You do it by finding the third angle. If two angles of the triangle are the same, that means that two of the sides would also be the same. So it's isosceles. And we'll talk more about that later. So we know that the angles of a triangle sum to 180. Given the two angles, we can find the third. On card 10, you were given two angles. When you find the third, you may have noticed that two of the angles now have the same measure. This is an isosceles triangle. Base angles are congruent. Since we have two angles that are the same, two of the sides are the same, card 10 is isosceles. Now we do the same thing with this card sort. We're going to sort them by their angles. When we sort cards, we sort triangles, we sort them by their sides and by their angles. Notice if it's got one right angle in it, then it's a right triangle. You can't have two right angles because that would mean the three angles would sum to 180. Two of them is 180, so the third one would be 0. That doesn't make any sense. So if you have a right angle, like is in this one, you only have one right angle, it's a right triangle. If it's obtuse, let's just say if they're all three acute, this was 58, 58, and 64. If it's obtuse, one of the angles is obtuse. This looks obtuse. I don't know if it is, but I think it is because it looks obtuse. This is equilateral, equiangular, and this is equiangular. Oh, I'm left with three cards here. Huh. Where do I put them? There aren't any angles marked. Well, what do we know? Wait a minute, here's one. This is going to be acute. Let's just check and see how many we have right. We have 14 cards, 11 of the cards right. We're missing the three cards. So everything is correct except for these last three cards. Well, let's talk about this. The fundamental theorem of geometry. Some people call it fundamental theorem of geometry. I do. It's the Pythagorean theorem. and it works for right triangles. It overarches and underscores everything that we do in geometry. If you don't believe it, try teaching geometry for 10 years or 15 years like I have, and you'll notice that this is really, really, really important. If this is true, it means that you have a right triangle. That means that a squared plus b squared is equal to c squared. Now, in our triangle, we have a 3, 4, 5. If you don't recognize this as a Pythagorean triple, we can always do the a squared plus b squared thing. So 3 squared plus 4 squared. Is that equal to 5 squared? Well, let's see. 3 is 9, 4 squared is 16, and yes, that adds up to 25. So yes, this is a right triangle because it fits the Pythagorean theorem. So I can move this over to my right triangle column. I have these other two, though, that don't. They look like they might be right triangles, but when I do the one, let's see, it's a 7, 7, and 10. It looks like it might be a right triangle. But if I do a squared plus b squared is equal to c squared, then I get 7 squared plus 7 squared is equal to 10 squared. That's 49 plus 49. 98 is not equal to 100. On the second one of these that we did, it was a 5, 5, and 7. So if you do the a squared plus b squared is equal to c squared, you have 5 squared plus 5 squared. That's 25 plus 25 is 50, and that's not equal to 49. 50 is not equal to 49. Now notice in this one, this would-be hypotenuse, if it was the hypotenuse, it would be the longer side, is less than this one. On this one, it's more than. Now I want you to look at my screen. I'm going to make myself nice and big here so that you can see this. This is one way of doing this. If you have a squared plus b squared, and you put your hands like this, seriously, just put your hands like this. If a squared plus b squared is equal to the invisible would-be hypotenuse, then it's a right triangle. On our one, we have 7 squared plus 7 squared, that's 98, is not equal to 10 squared. 10 squared is going to be longer. That makes this obtuse. This is going to be an obtuse angle. If we have 5 squared and 5 squared, that's 50, and the would-be hypotenuse, 7 squared, is 49. It's going to be shorter, so it's going to be acute. And that's how you would know. If it's the a squared plus b squared doesn't work, a is equal to c squared doesn't work. If the would-be hypotenuse is longer, it's going to be obtuse. If it's shorter, it's going to be acute. So now, let me make myself small again, make this video small. I know where to put this. This would be obtuse, and this would be acute. And acute. All of my answers match. We go on to the next page. Sure enough, they all match. And we have this short discussion. Question 7 was the one at 3, 4, 5. If we use the Pythagorean theorem, we know that it's correct. These other two are the ones that I explained. And I go on to explain it in this card as well. Fundamental theorem of geometry, the Pythagorean theorem, a squared plus b squared is equal to c squared. This works if it's a right triangle, and c would be the hypotenuse. So the longest side would be the hypotenuse. Here we have 3 squared plus 4 squared is equal to 5 squared. So this is a right triangle. On these other two cards, we do the thing here. If it's long, if the would-be hypotenuse is longer, it's going to be obtuse. If it's shorter, like 5 squared plus 5 squared is 49. No, 49 is going to be shorter than 50. It will be acute. On this page, I give you a graphic organizer on how we sort triangles, how we classify them by their angles and by their sides. And there's 3 classifications here I want you to take note of. You can't have equilateral and it be obtuse or right, because it's got to be one of these acute. It's going to be equiangular. You can't have equiangular and have it be scalene, because if it's got equal angles, it's going to be isosceles. It's going to be equilateral. It's going to be isosceles. Now, previously in this course, up to this time in lesson 21, we proved 3 times the triangle angle sum theorem, which says that in a triangle, the sum of the measures of the angles is 180 degrees. We also proved the triangle exterior angle theorem, which says, and I'm going to show you this on the screen here, if I have a triangle and I label its sides x, y, and z, these 3 angles equal sum to have their angles sum to 180. So x plus y plus z is equal to 180. And if I extend this one side, this we'll call W. This makes a straight angle. So we have w plus z is equal to 180. And as you can see from this diagram, the w has to equal to x plus y. An exterior angle is equal to the sum of its remote interior angles. That's what the exterior angle theorem says, the triangle exterior angle theorem. And today we're also going to use that plus an extra which is called the Isosceles triangle theorem. The Isosceles triangle theorem is an assertion at this point. We think it's true. We will test it out and we will make a conjecture that it's true. And then we will prove the conjecture to make it into a theorem. And the theorem says that the base angles of an isosceles triangle are congruent. Base does not mean the bottom. I could turn it on its side, it'd still be isosceles. So we're going to assume that that's true today, and we'll use that property, but later we will actually prove it. Now, in this lesson, you're going to put your work in the sketch. You can put your answer in the text box. So for example, I'll show you how I would do this problem. I know that these two angles here sum up to, let's see, 58 plus 46 sums up to 104. I also know that the three angles, the 104 plus the w, have to add up to 180. So if I subtract 104 from 180, I get w is equal to 76. And I can type that into my answer box here, 76, and I can look at the answer. And sure enough, it's 76. Now, as you work through these problems, as you work through these problems, don't just look at the answers. Try to figure them out yourselves. If you can't figure out the answer, or your answer is incorrect, try to figure out what it is that you did incorrectly or wrong to get the wrong answer. If you have questions, you can ask later on, and we'll go through it. On some of these, I not only give the answer, but I also give the solution. Let's see if I can find one here with a solution in it. Where, like for instance, here we have the solution. This tells you how you would go about solving this for x. And some of these make more sense to look over. Anyway, these are the practice problems that I have for you for today. Good luck and success.